Hello, everyone. Good afternoon and welcome to Super Friday. Do you have any questions before we begin? Anyone? All right, so we are into the whatever you call week 3 or week 4 right now, okay, according to the calendar. So we're gonna enter the chapter 2, okay? Chapter 2 probably a little bit bigger chapter. Um, for the function, more on function. We actually talked a little bit more on the chapter 1. So let me share my screen a little bit so that way you know. Some people were asking where do we find the test 1 mistake, something like that. To look at the test 1 test question, you will need to go to the all right. You will need to go to the grade book. Okay. So go to open the Pearson, the MindLab Math. All right. And you do need to allow the cookie all the time. So you launch the course here and you don't click on the test, because if you click on the test, it will ask you to you know have another attempt, right? And that is not the case. So if you go to the view students home, all right, and then if you click on the entire course today, not just the colon, right? You click on entire course today, and then click on the grade book. Okay, so student grade book in here, all right. And then you can see like, all the assignment. Instead of the past 2 weeks, you can click on the entire course today, right? And then you can click on the review. Since I didn't submit the test here, so but whatever the test that you submit, you will be able to look at the test and open a review from here. Okay. Once you open a review, it will telling you which one you made mistake and what is the correct answer, what is the incorrect answer you enter. Okay. All right. So you can always come to look at that. You will need to go to the student grade book here. Okay. Go to the you will need to go to the student grade book and then open the entire course today, and then you can choose whatever the test or the quiz you want to review. All right. So that is the first thing about that. Okay. If you look at the announcement here, okay, the announcement according to the one we have, this is week um 3. All right, so you will need to start section 2.12 and 3. All right, and then next week will be considered a week 4. All right, so week 4 you pretty much need to finish the this is next week, right? So by the time next week we meet, you will need to finish pretty much the entire chapter, okay? And then next Friday we're gonna review for the chapter 2 test. All right. So we're gonna go ahead and look at what is on chapter 2 for now. Okay. We're gonna start with 2.1 in here. All right, so the chapter 2 here, this one is more on function, right? Function and graph, which is very important one, okay? Function and graph in here. One thing here is we need to know how to find the domain and range, okay? And domain is all the x value, and then the range is all the y value, okay? And then how do you identify a function? Is a function or not. Okay, so we are using the vertical line test to identify the function. It has to pass the vertical line test in order to qualify to a function. All right. Okay, so with the domain and range. A relation is any set of the ordered pair, right? So what is this ordered pair? We usually say this ordered pair is the x and y. Okay, the ordered pair is x and y. And the set of the fourth component, which is the fourth set, okay, we call the fourth set here. This is the x value. This is called a domain, all right? And the second set or the y value is called a range, okay? All right, so look at this one right here. All the x value is considered a domain, right? This is all the pair. So all the 0, 1, 2, 3, and then y value is called a range. All right. And a function is set of the relationship between x and y. Okay. So a domain is correspond if one x only corresponding to one y, we call this one is a function. All right. One x only corresponding to one y is a function. It can be a same y. A different x can have a same y, but you only need to have a one y. All right. So look at this one right here. If you look at this one, I usually like to write down in a organized, right? 1 corresponding to 2. So this is x, this is y. And then 3 corresponding to 4, 6 corresponding to 5, 8 also corresponding to 5. Okay. All right. So even they have a same outcome 5, but 1x, 1, 6 corresponding to only 1y. 1a is also corresponding to 1y. So actually this one is still a function. So yes, that is still a function. Okay. Um, all right. So that is the function relationship. Okay. Um, if we determine this equation represent a function or not, apparently this one is a circle, right? If you go to graph this one right here, this one actually is a circle with a center in the origin, all right? And then if I go to solve for y, right, you minus x squared on both sides, right? And then you have a y squared, this cancel out. So you have y squared equal to 1 minus x squared. Take the square root, you're going to have a plus minus, okay? So that means 1x, you're going to have a corresponding to 2y. Look at that. If I do a little bit vertical line in here, this pass 2 points in a graph, okay? So when you draw a vertical line to the graph, you pass in more than 1 point. So this one actually is not a function. All right. So this equation does not define as a function of x because it didn't pass the vertical line test. Or we say 1x don't have a exactly 1y. 1x is going to corresponding to 2y, right? Look at that. You have y equal to plus minus. So you have a 2 value of the y. We usually like to using f of x as a function notation, right? So if I have a y equal to x plus 2, I can write down f of x equal to x plus 2. So this one is called a function notation in here, okay? And we like to use the function notation instead of just y because if I want to calculate f of 3, right? And it's very easy. You just replace x by 3 and that is 5. So this means x is 3, y is 5. All right. So this is a math language, right? So I don't really have to write down the whole sentence of a statement here. Say, please find the y value when x equal to 3, right? I just write down f of the 3. So you know what to do. F of the 3 will be equal to 5. All right, so that is called a function notation. Look at this one right here. This is a quadratic equation. I want to evaluate the y value when x equal to -5, right? So I can just say, find the f of the -5. And you should know what to do. this x is a variable. X can be replaced by anything inside the parentheses. So I want the x equal to -5. So all the x are going to replace by -5, right? And then you go to calculate this whole thing. So the answer here will be 42. So that means when x is equal to -5, y is 42. Okay, so that is what I mean in a function notation here. All right. Graph or the function, you can graph these two in a same coordinate, right? So you can also using a calculator, but basically this f of x and g of x actually is the same graph, but moving down for 3 units. Okay, moving down is the g of x graph is f of x graph moving down for 3 units. All right. So we can put it in a calculator, graph them very quick. Okay. We also need to know how the function move in this kind of situation. Okay. So that is these two are pretty much parallel. All right. Okay. So I go to y equal to, right? We have a y1 is 2x. Okay. And then we graph them. Oh, hold on. All right, not 22. It's just 2. Okay, so that is the straight line passing the origin, right? And then if I have my 2x minus 3, okay, and then I graph them, you can see these two lines are parallel, and this one is moving down for 3 units. All right, so that is this one right here. Yeah, so that is how the graph g of x compared to the graph f of x. All right. And you can see, you can go to do a little bit table to do the calculation. But basically, this function is, they also have a same slope, right? If we write down y equal to mx plus b, this is a linear equation and m is the slope. Okay, n is the slope in here. And you can see that when the m1 equal to m2, two lines are parallel. Okay, so this m here is 2. This m here is also 2. Okay, so m1 and m2 are equal. That means two lines are parallel. This only apply to the straight line, of course. Okay. All right, vertical line test of the function. If any vertical line test intersect a graph in more than one point, the graph does not define the y as a function of x. So only have more than one point. So basically, the graph will need to pass vertical line test. All right. So only one point. So if you look at this one right here, right? It doesn't matter where I drop the vertical line, either in here or in here or in here, right? This is all just passing the graph one point. So yes, this one is a function. And if I graph this one right here, look at that, this is circle, 1x, this is the same x value, but you have a 1, 2y. One is positive, one is negative y, right? If you graph this one right here, same thing, you also have a 2y. So this one is not a function because it passes more than one point. Okay? In order to qualify to be a function, you have to pass exactly only one point. All right? Okay, is this this one you want to using the graph to find the value? So this basically is just reading the graph. Okay, reading the graph in here. So when x equal to 5, you can see when x equal to 5, 5 is right here, right? And then just in here. So y looks like a 400. Okay, 400. This is average T-shell count. Okay, per milliliter of the blood. All right. So when the time infection after time after infection in years, right? So after the infection, after 5 years, okay, and you can see the average T cell, right? Whatever the T cell do, right, trying to fight the infection. All right, so the Y value is 400, okay, 400 millions in a blood count. So I think that is, you can do the blood test to identify a person, got this one is the HIV infection, right? Horrible one. Okay. All right. So in what value of x, f of x is 100. All right. So we want to counter this 100, right? So 100, we want to find the x value of y. Oh, hold on. I don't know the. What's like my, is it my computer or someone else? All right, so that's like the computer, the fans get really down. That one. Let me try to see if we can make it a little bit. All right, that's a little bit better now. Okay, can you still hear me, everyone?
Yeah, I can hear you fine.
Okay, all right, okay, good. All right, so we are in 2.1. So this one is finding the x value on y is 100, right? So we're gonna have to go to look at 100, which is a half of the 200 here, and then do a horizontal line, right? Do a horizontal line, and then trace that, and then looks like there's an intersection point right here. Okay, so now you have an x value in here. X will be 9. All right. So basically, in this section, we just also need to know how to read a graph. Okay. Um, Domain and range. Okay. So how do we identify the domain and range? So basically, I'm gonna look at a little bit clear picture. Okay. So this one is a little bit clear. Domain and range, domain is all the x value, okay? And the range is all the y value. So if I look at this graph in here, I look at the x value. So trace this one back in here. X here is -2, but this one is a circle. So what does a circle mean? Circle, that means it's not equal to -2. All right, so that's why we need to use the parenthesis or not include the equal sign, right? And then this x go all the way to the right in here. So this x here, apparently this is 1, this is 2. So this is a solid dot. So that means include 1. All right. So that is how you write down the inequality. This is how you write down in the interval. Okay. The circle one, you using the parenthesis. The solid one, you use the bracket. All right. And with the y value, remember y, you need to write down from the smaller one to the larger one, right? So smaller one will be down here. Smaller one will be -1, right? This is y corresponding to -1, and it's a solid dot, so you need to include the equal sign. Okay. This one y go all the way up here to 2. So 2 is a circle, so you don't use the equal sign. And actually, this one is wrong. Okay, so let me go ahead trying to see if I can fix that one. This one should be the parenthesis, okay, for the interval. All right, because the y doesn't include a 2. Okay, this point is a circle. So for y, this inequality is correct, but the bracket here, the interval notation here should be parenthesis. Okay, so that's how we find the domain and range. So domain, remember, domain is all the x value, range is all the y value. All right, and then reading the graph. We also need to know how to find the x-intercept, find the y-intercept. I think we talked this one in the fourth section, right? If you want to find the intercept, you look at the graph crossing the x-axis. To find the y-intercept, you look at the graph cross the y-axis. All right, and look at this. This looks like a qubit graph. Okay, What is my x-intercept in here? We can see there's 3 x-intercept here, right? And then this is from -3, -1, and 2 in here. And then the y-intercept is a graph passing the y-axis, okay? So y will be -6 in this case. So this section is basically just reading the graph, all right? And then, okay, by the way, is this a function? So does this one pass? We call it VLT. In order to be a function, we have to pass the vertical line test. Does this pass the vertical line test? If I drop a vertical line anywhere, how many points do I have across the graph? All right, give me a yes or not. Is this a function?
Yes, it's a function.
Okay, that's good. That's exactly right. This one, it is a function. It does pass the vertical line test. Okay, so that means I drop a vertical line anywhere, it only crosses 1 point to the graph. So yes, it's a function. All right. Okay, all right, good. So that is one section already. All right, so shouldn't be too bad, that one. Okay. Let's look at the second section, a little bit more calculation, a little bit more on graph actually. All right. And we want to identify which interval the function increasing, decreasing, and find the relative minimum, maximum, right? And then how do you identify the symmetry, okay? And another a little bit tedious one here is the piecewise function. How do you graph the two pieces of the graph into one coordinate, all right? Okay, so increasing, decreasing, constant. We're going to look at this graph in here a little bit easier. So the increasing one, basically from left to right, x is always increase, right? From left to right, x is increase, okay? x1, x2 is greater than x1, all right? And then y2, so this one is y2, right? We're using f of x2, and then for y2, this will be y1. So from left to right, x is increasing, y is also increase, all right? So we call this is an increasing function, okay? And then from left to right, x is also increased. But you look at this y1 and y2, right? So y2 is decreasing, y is decreasing. Okay, so this is called a decreasing function. All right. And from left to right, x2 is also greater than x1. Left to right, x is increasing. X is increasing. But y1 and y2 are the same, right? So y1 equal to y2. So this one is called a constant. Okay, so it should be really easy to identify. One thing is when you want to write down an interval, you have to write down an x interval. All right, so look at this one right here. Standard interval on the function is increasing or decreasing, right? And then look at this one right here. We have a little bit called the refraction, the inflection or the inflection point. It's called it inflection point in here, right? And then this one going up, and then after this one it become going down, right? And then this is going down after this point it become going up. Okay, so from negative infinity all the way to -1, this is increasing. All right, and then from this -1 to 1, this is decreasing, and then after 1 it increases again. Okay, it increases again. All right. So that's how you write down the interval notation. One thing is you will need to read the graph, okay? And then you look at the y increase or decrease, but you have to write down the interval is x interval, all right? Relative minimum and maximum, why you want to use the relative instead of just minimum or maximum? Relative, I usually say a little bit like a local, okay? So local minimum, local maximum. So the relative and the local is similar. That means they can have a more than one, can be more than one in a graph, okay? If I ask how many city champions can you have instead of Texas? Wow, there's a lot of cities instead of Texas, right? You can be a Fort Worth City champion, you can be an Arlington City champion, you can be a Dallas City champion, whatever. So relative means local. All right. So that means compared to my left and right, I'm in the highest one. So I'm already a relative maximum. This one you don't call the absolute maximum or just the maximum because this is going up indefinitely. All right. So it's only local. Okay. But local means you can have more than one. All right, so this one you have a relative maximum in here, also have a relative minimum in here, right? And I can graph this kind of graph. Okay, I can have a several. So this is relative minimum. This is also the relative minimum, right? And I have a relative maximum here. I can also have a relative maximum here. So relative can have a more than one. Okay, a little bit test for the symmetry. All right. We can do the visual way. We can also do the algebra way, or we can even do the graphing way. Graphing is the visual way anyhow. Okay. So what kind of situation is symmetry around the y-axis? Well, I can give you this parabola, right? If I have this y equal to x squared or f of x equal to x squared. Apparently, this one is symmetric with this y-axis. Okay, so from the visual one, symmetric with the y-axis is I choose a random point and then do a little bit graphing perpendicular to the y-axis and then extend to the same distance. I can find my p prime. I can find my corresponding point on this side, and that is called symmetry around the y-axis. Okay, in the algebra way, here is you substitute x with negative x, and you still produce the equivalent equation. So basically, produce the same equation, right? And then we call this is symmetry with the y-axis. So look at it. If I have a f of negative x, what happened? I replace the x by negative x. And the negative square is still positive. Okay, so basically I prove f of the negative x basically equal to f of x. F of x is x squared. F of the negative x is also x squared. So actually this we also call it is an even function. Even function. Okay, so if a graph is symmetric with the y-axis, or you can prove f of the negative x equal to f of x, this is considered even function. All right. And graph, if you replace x with negative x at the same time, also replace y with negative y. And this one actually is considered symmetric with the origin. Okay. And symmetric with the origin is also called R function. So what kind of graph is symmetric with the origin? Like y equal to x cubed. Okay, so I write down f of x equal to x cubed. And then if I replace y with negative y, I replace x with negative x, right? And then we're going to have a negative y equal to negative x cubed because negative 1 to the cube is still negative. And I can multiply both sides by negative 1, so I still get a y equal to x cubed, right? So that means if I replace x by negative x, I will get a negative x cubed. So this f of negative x is not equal to f of x, right? Not equal to. Look at this one right here. So this one we call this is not an even function, not even. All right. But this one is an R function. So what is an R function? If I can produce f of the negative x equal to negative f of x, this will be an R function. All right. So if I have f of the negative x, which I just f of negative x, I already equal to negative x cubed, right? And then if I calculate the negative f of x, what happens? I just using the negative multiply the entire f of x, which is x cubed. All right, and then this is also negative x cubed. So these two are the same. These two are the same. Okay, so we call this one is a R function when it's symmetric with the origin. All right. One thing is symmetric with the x-axis. if you have a graph symmetry with the x-axis, it will be something like that. Okay, we have this x equal to y squared. All right, symmetry with the x-axis is not an even, not an up. Okay, so if I graph a point P corresponding to a perpendicular line with the x extend to the same distance, I can find this point right here, right? So that is a symmetry with the x-axis. This one is you replace y with negative y, and you still produce the same equation. So I have x equal to negative y squared, right? Because x equal to y squared. So I replace y with negative y. And this negative square is still positive. So even I replace y with negative y, I still come out the same equation as this one. All right. So that is considered symmetry with the x-axis in here. All right. So that is pretty much this section. We need to know the graph symmetry with the x, y, or origin. When it's symmetry with the y, is also considered an even function. Okay, and symmetry with the origin is considered an odd function. So what does symmetry with the origin mean? If I find a point P here in the graph, and then I connect to the P with the origin, extend to the same distance. All right, I can find a corresponding point here. That is considered a symmetric. All right. Any questions?
Yes, so the one corresponding to like the symmetry with the x-axis, would that be considered neither even nor odd?
Right. That's exactly right.
Okay.
Yeah, it's neither one of those. Only symmetry with the y is an even. So look at that. This is an even function. Even is replace the x by negative x. They still produce the same outcome. All right. And this is the r function in here. F of the negative x equal to negative f of x. That means I replace the x with negative x, replace y with negative y at the same time, and they still produce the same outcome. So that is the r function. Yes. Yeah, and according to your description, if graph with symmetry with y would be the even, symmetry with the origin would be the odd. But if it's symmetry with the x, it's neither even nor odd in here. All right, so this one you will be able to use a little bit of algebra to prove them in here. Okay, a little bit. Look at that one. The next thing here is a little bit called piecewise. Let's see. Yeah, the called the graphing the piecewise. Okay. So what is a piecewise function? A piecewise is two or more equation over a specific domain. It's called a piecewise. So that means you graph the x. X has a limitation. X won't be all real number. Okay. If you look at this one right here, okay. This is a piecewise, okay? It doesn't look that pretty, but this one is still a piecewise. So this function read like a g between 0 to 15. Y or c of the g or y will be a constant number, right? Will be 40, okay? And then if t is greater than 15, and then this function will become this one, right? This is probably, like I say, if I using this function for the electricity cost, okay? And then if you use customer use between 0 or less than equal to 15 kilowatt, something like that, right? And then you have a constant rate, okay? A constant rate is 40. And then if you use more, now we're going to have to get charged more, right? If you use a lot of electricity, now we're going to charge you more. Because now you not only just 40, but 40 you have to plus 0.6 and then whatever the greater than 15, right? G minus 15, whatever greater than 15, you're going to have to multiply this 0.6, something like that. All right. So those are the piecewise in here. Okay, so how do I graph this one right here? This is a piecewise, right? And you can, this will be pretty much a typical test question, right? One is constant, one is linear. Actually, it's very easy to graph, okay? So if I draw for this one by hand, x less than or equal to -1, okay? So that's -1, 1, 2 in here. This will be 1, 2, 3, right? Okay, so on x less than or equal to -1 here, y is a constant. So this is y is constant, 3, okay? And I actually have a solid point right here because this has an equal sign. Oh, I'm sorry, I already made mistake. You know why? Because I overdraw the x value. All right, we just said that earlier x is not less than or equal to 0, but less than or equal to 1. So you have to start from here, okay? And then go all the way to the left. All right, so this should be empty in here. All right, start from here. X can only be less than or equal to 1. So since this has an equal sign, so I'm not using a solid dot in here. And then this go all the way to the left. Okay, and you can see when x is equal to -1, -2, or -3, y is a constant, right? And then the second one, this x greater than -1, but didn't have an equal sign. So you're gonna have to using if you evaluate -1, this point, right? Replace x by -1 in here, you have a -3. This one you're gonna have to using a circle. Okay, you have to exclude this point. All right, so -1 and -3 will be right here. All right, you have to use a circle. And when x is 0, this will be -2, so it will be something like that. All right, so that is your piecewise. You cannot drop this down, you cannot graph this one over. All right, so basically piecewise is nothing but just you have to control the x value. All right, yeah, that is how you look at that in here, right? And sometimes people say, can I graph the piecewise in a calculator? The answer is yes. A little bit more complicated than you want, but you can graph the piecewise in a calculator. Okay, I can even show you how in here. Okay, we have a y equal to, let's see, y equal to 3, right? If I graph y equal to 3, what happened? The default x will be all real numbers. So this will be graph from all the way from left to right. All right. So when you have a piecewise, you have to do a divide, and then using the parenthesis, and then limit the x value. Tell them x should be less than or equal to -1, right? And where do you find the less than or equal to? Go to second, just go to math. No, second math. All right, and then you go to the number 6, less than or equal to. All right, -1. And then close your parenthesis. So this under the denominator, so this one actually is telling you the syntax here is telling you the calculator only graph the x less than or equal to -1. Okay, and you can see the graph is stopped right here. All right, it won't be run wire everything. And then if you go to look at the table in here, look at it. When x greater than -1, this will be all undefined, or giving you the error. Okay, because we limit the x domain is only less than or equal to -1. All right. Very similar with the second piece, right? Second piece, I have x -2, x -2. All right. And if I do not give you a limitation, this will be graphing from all the way from left to right, right? Because x can be all real number. Okay. So if I want to do the piecewise, I have to very similar. I have to control the x value. Okay. Give me oh, all right. Using the parenthesis and then set the x value. X should be greater than 1, right? Greater than using number 3. Okay. Greater than -1, I think. Greater than -1. Oh, greater than 1. This should be greater than -1. Look at this one. Yeah, this one should be greater than -1, right? This one did not copy this down in here. Okay, so let me give it a little bit of fix in here. All right, so x should be greater than -1. All right, and then we go to the graph, and then you can see this one right here is it only graph the portion you want. Okay, so that is the piecewise. Okay, you can do the calculator if you want, but I think easier to graph by hand that way, right? The last piece for this section here is you will need to be able to calculate. This is called average rate of change. Okay, average rate of change. All right, so we have actually this is a slope, believe it or not, this is a slope equation. Okay, so why this one is a slope equation in here? This average rate of change can calculate any kind of slope. All right, so using delta y over delta x, or sometimes in a linear, we're using y2 minus y1 over x2 minus x1, right? And this is called a difference quotient of the function, okay? If I have a random graph, okay, this will be my x1, this is my y1, right? And then I choose the second point, x2, this will be y2. All right, so if I connect these two together, it's a straight line, right? So I can find a slope for this straight line. All right, and this instead of using the x2, I'm gonna using the I can change this one into the, look at it. I can change this one into x, and then I increase h, and then this point will be x plus h. All right, and my y here, my y here, this will be f of x, right? My y1 here will be f of x. And my y2 here will be f of x plus h. All right. So, and then I pocket the y2 in. My y2 is f of x plus h, right? My y1 here is f of x. Okay, my x2 here is x plus h minus my x1 here is x. And x cancel out, so that's why we got this denominator is only h. All right, so this actually is a slope calculation. If you go on to the calculus, you will see like, you can find all the slope using this equation. Okay, that's the definition for the slope. Not only just linear, but can be for cubic quantity. One thing is when h is really small, right? Very small, close to 0, but not equal to 0. All right. And then when x and x plus h, x1 and x2 are really close, you can see that small piece is a straight line. Okay. One thing is how do you find this one right here? I'm going to give you a quick example in here, right? So if I have my f of x equal to 5x plus 1, how do I using this find the slope? We know this x plus h, okay? This will be 5 times x plus h plus 1, right? And then if I have a f of x minus f of x, and this will be multiplied in. So this will be 5x plus 5h plus 1, right? Minus f of x will be 5x plus 1. And then you can see this 5x cancel out, this 1 and 1 cancel out. So this will be just 5h. So my slope here will be f of x plus h minus f of x over h. We just calculate this whole thing equal to 5h. All right, and then h cancel out, so this is equal to 5, right? We just prove this slope for this linear equation is 5. So yes, we can write down this one is mx plus b. My m here, it is equal to 5. Look at it. All right, but using this one is prove the slope. Okay, prove the slope in here. All right, so that is basically our second section already. Okay. Look at our So the section is a linear equation and a slope, which we just did a little bit linear equation, okay? You need to be able to find a slope point and then the horizontal line, vertical line, right? We have a slope formula, which I just did it earlier, right? Using the rise over length or change the, we can call it delta y over delta x, or y2 minus y1 over x2 minus x1, right? So that is the slope formula, okay? And given you 2 points, you should be able to find the slope. So I usually say, mark, this is x1, this is y1, this is x2, that's y2, right? You give it a little bit mark and then plug it in. All right. Sometimes people say, I know what it is. I don't have to mark. If you don't mark, it's very easy to make mistake, believe or not. So I usually recommend people say, go ahead and mark that. All right. So it's easier to calculate. And this is called a slope point formula. So if I know one point and the slope, I can write down the equation for the line, right? Y minus y1 equal to m times x minus x1. This one is very popular formula. You can also write down y equal to mx plus b form. But if you want to write down this one, you have to find a b, okay? And if I know the point x1, y1 already, I can just using this formula, and then you can convert it into this form. Okay, so this one will be easier. All right, if you have a slope is 6 passing this point, what is the equation? Well, look at that. Slope is already given to you, right? So this is your x1, y1. All right, so plug in x1 is 2, y1 is negative 5. And then you simplify into the y equal to mx plus b form. So your slope here is 6. Okay. All right. So this, and it tells you slope is 6. So that's exactly right. Okay. And then your y-intercept is when x equal to 0, y will be negative 17, right? So that is the slope point in here. Okay, slope and y-intercept form, you can use y equal to mx plus b. All right, so that should be really easy in here. Okay, if I have given you this general equation, how do you find a slope? How do you find a slope here? What is my m? Okay, and this one you also want to find the x and y-intercept. X-intercept. X-intercept, y will be 0, so this will be 0. Look at it. All right, so y is 0. And then you have a 3x minus 6 equal to 0, or x will be just 2, right? And if you want to find the y-intercept, x will be 0. Okay, so this will be 0. So you're going to have a negative y minus 6 equal to 0, or negative y equal to 6, right? Divided by negative 2, so y will be negative 3. All right, so this one will be 0 and negative 3. If you go to make a graph, you're going to have a 2 and 0. All right, 0 and negative 3. So it will be these 2 points, passing these 2 points, like that. All right. So that is your x and y intercept. If I want to find a slope, I have to write down y equal to mx plus b form. Okay, if I want to write, if I just want to find a slope in this one, so that means I need to isolate this y, right? Everything have to go to the other side. So, or I can just move y to the right-hand side. Actually, this will be easier. I'm gonna just move y to the right-hand side. So I'm gonna add a 2y on both sides. Okay, just by watching this one, this will be easier. So this will be canceled out. And then we're going to have a 3x minus 6. 3x minus 6 equal to 2y. And then I just divide by both sides by 2, right? So my y here will be 3 over 2x minus 6 divided by 2 will be 3. So my m here is 3 over 2. Look at that. My m here will be 3 over 2. So if I want to put this whole thing in a calculator, I will have to solve for y. Okay? So look at this one right here. If I want to graph the entire things in a calculator, now I need to have a 3 over 2, okay, x. Let's make it a little bit easier. Okay, oh, hold on. All right, so I have a 3 over 2, okay, 3 over 2x minus 3, and then we're going to hit a graph. All right, so look at it. I have an x-intercept here. This is x is 2, y is 0, right? And then this one, y-intercept when x is 0, y is negative 3. Or you can go to look at the table, okay? Look at the table in here. When x is 0, y is negative 3, okay? And then when y is 0, x is 2, all right? So that is this one right here. If you want to put a whole thing in a calculator, this one you cannot put a whole thing. You cannot put a 3x minus 2y minus 6 equal to 0 in a calculator, right? You will need to solve for y, okay? And apparently this is the same graph as we just did in here. All right, so that is this one right here. You also have to understand here is if two lines are parallel, okay, this is called a general form, okay, and then the general form is ax plus by plus c equal to 0. Slope intercept form is mx plus b. Point slope, so that's a slope intercept, right? And then you have also have a point using point and a slope form is y minus y1 equal to m times x minus x1. So you have a three different form in here. Okay, this is called a general form. All right, this is called a slope and intercept form. Okay, and then this one is a slope point or point slope, whatever you want to call. All right. And if two lines are parallel, okay, there's a relationship you also have to understand. Two lines are parallel, the slope are always equal. M1 and M2 are always equal. All right, so that is the section 3 already. Okay, we pretty much can giving you a little bit summary for all these sections. All right, I just want to let you know like what to expect on this chapter. 2.4 is more on slope, right? So yeah, we're gonna talk more on slope. So maybe we'll talk that relationship. Okay, parallel and perpendicular. All right, yeah. Okay, so what does parallel mean? Parallel means two lines never intercept each other. All right. Okay, so let's look at the parallel slope and rate of change. Okay, talked that earlier. All right, this doesn't really help that much. I want to say like the two lines are parallel here, M1 and M2 will be equal. If two lines are perpendicular, M1 times M2 will be equal to -1. Okay, so what kind of situation two lines are parallel? We have a 2x, y1 equal to 2x earlier, and then y2 equal to 2x minus 3, right? So you can see this M1 is 2, M2 is also 2. So they are parallel, okay? And we graph this one earlier, okay? We graph this one. All right, we have a 2x, okay? And then we have a 2x. You can either plus or minus 3, it doesn't matter, They are all parallel, right? And you can see these two lines never intersect each other. So they are parallel, okay? And what kind of situation that will be perpendicular? I can graph a perpendicular line to this one, right? The slope will be, if I giving you the M1 equal to 2, what is my perpendicular slope? Well, the perpendicular slope here will be negative reciprocal, okay? So if I have M1 equal to 2, my perpendicular slope will be negative 1/2. All right. So if I have my Y3 equal to negative 1/2 x, okay, whatever plus minus 3, these two lines, this gonna be perpendicular. This Y3 gonna be perpendicular to Y1 and Y2. Okay, we can make a graph in here. I can actually, we can even graph a little bit more. We can have a 2x minus 3. All right, and then you see these two lines are parallel, right? And I'm gonna graph my y through here will be negative 1/2x. All right, and then graph them. All right, so you can see this y through, yeah, it is perpendicular to both of them in here. Okay, so perpendicular, that means they intercept 90 degrees. All right, so that is the perpendicular line in this case. Okay. Let me go to find some of the lectures note in here. Okay, so a little bit application in there, but I will leave this one later on.
Quick question: are we allowed to have their TI-84 on the test, or do we have to just use the calculator on the
Yeah,
lockdown?
you're allowed to use TI-83 or 84 calculator, the handset. Yes.
Oh, okay,
Yeah,
awesome.
yeah. So not a
That
cell
helps a
phone
lot.
one, not a cell phone calculator, but a handset calculator is allowed. Yeah, that would be helpful. Yeah, for the at least the
Yeah, I thought I
graphing.
wasn't allowed to for some reason. I thought I was only allowed to use the one on the computer, and so I was struggling with that.
Oh yeah, no, you can use the TI-83 or 84. Some people asked it before, so I thought I already answered it, but apparently not quite. But
I
yeah.
didn't realize this class had a lecture until now. I was the one who emailed you just now, so that was my
Oh
bad. This is my first time here.
oh okay. Now you know you can use that.
Yeah, it's very exciting.
Okay, good. All right, so let's look at 2.5. Yeah, because it does really helpful, for the
Saves a lot of
um
time.
yeah, save a lot of time, and I want people to understand the principle and the concept, but not the tedious calculation, right? As long as you know how to calculate, um you can find all the tedious answer from calculator, basically. All right, we want to uh use the energy to master the most important thing, not a tedious calculation that way. Okay. So this one is a transformation of the function. So basically, we need to know how the graph will moving left and right, top and up and down, and shrinking, stretching. This kind of graphing in here. Okay. Um, some of the basic function here, you kind of need to have a little bit idea, right? Like an absolute value, square root, cube root, how the graph look at that. If you don't, you can put it in a calculator, but it's helpful to know this one. So that's the cubic, that's the absolute value in here, right? Like a V shape. Okay, and then you know that y equal to x squared, right? It's a parabola. Okay, and then the square root. Oh, now we're gonna need to look at the domain for this square root. Domain here, x have to be greater than or equal to 0. So if you go to graph square root of x, you're gonna look at something like that. Okay, and the cubic here, cubic x is all real number. So that look like that. Same thing as the Q loop. So Q loop is R root. R root X can be anything. This is an even loop, right? Square root is even loop. So domain has to be greater than or equal to 0. But this one is a Q loop. So Q loop X can be, can do that. Q loop X can be anything. So you can have this one to the left and can also have this one to the right. All right, because this is R root. And if you really do not know all this graph, you can put in a calculator. Okay, so that's just giving you a little bit calculator graph. Compare the square root and the Q loop. All right, so that's the second x squared. That's the square root, right? So if you graph the square root of x, that's how you look at that. Okay, and you can graph the Q loop. One thing is Q loop. If you don't, you can go to this one, go to math, and then find the Q loop. Number 4 is the Q loop. Okay, Q loop of x. All right, so you can see the Q loop of x can be anything, right? It can be negative, can be 0, can be positive. You can also go to the table to look at it. Look at the x, when x is negative, the square root all giving you the L, right? And the Q loop all has a negative value in here. So that's the domain for the square root has to be greater than or equal to 0. But for the Q loop can be anything. All right. So yeah, the graphing calculator can be pretty helpful that way. So you need to understand what is a domain, right? Domain is all the value a function can have is a domain. If the domain is all real number, we're using the negative infinity to positive infinity, okay? That is the domain. The absolute value domain x actually is all real number, but the range y is only from 0 to infinity, right? That's the range y, the range, okay? And then on this side is decreasing, right? And then on this side is increasing. So you have a decreasing domain of x is negative infinity to 0, increasing domain, increasing interval, which is the x interval. The x interval. You have to write down the x interval. It's from 0 to infinity. All right. So let's connect to our increasing, decreasing earlier. This is a parabola, right? The y equal to x squared, and you can see this part is decreasing after the vertex. After the vertex, it becomes increasing. All right. So the domain here, domain is all real number for this one, right? And the decreasing. So this part is decreasing. Decreasing will be from negative infinity to 0, right? And then after this one is increasing. After this vertex is increasing. All right. So that's the domain for the increase. Okay. The function is also an even function because you can see it's symmetric with the y-axis. All right. And you can replace f of negative x equal to f of x. So that's the even function. All right. We also, okay, so I want you to pause a little bit here. Let's see what is the f of x equal to, what is the domain for these two functions? One is square root of x. The other one is square root of x minus 4. We know domain is very important. So I want you to go ahead and find a domain for these two. Okay. I'll give you a couple minutes. Let's see. How do you find a domain? How do you find a domain for these two? I'm gonna call the second one is g of x instead. Okay. Call this one is g of x. So we want to find a domain for f of x and g of x. I'm gonna put you in a group for a second, okay, for a minute, and then trying to write down this one right here. I want you to talk to each other to trying to see how do you find a domain for these two, and what is the range as well, domain and range. So I want you to find a domain and range for both x and g. Okay, and I'm going to separate you into probably two groups in here. All right, so um, two group in here. Uh,
I wonder why it says I can't access breakout rooms.
for some reason, you said you unassigned in here. Okay, do you go into maybe do you sign into the Canvas account? If you go sign in,
Uh,
if you only just click the link, you that's probably why. If you sign in
oh,
to
okay.
the Canvas, if you just disconnect and then go to Canvas, I send an announcement in here. Okay, so let me show you where to join. You go to the course. Okay, go to the course and then go to the Microsoft Education here, and then click the meeting. Click the meeting here, and then you click join. If you go there, you
Okay,
should
one
be,
moment.
yeah.
It's
So
loading
go
and
to
then
the
I'll
log into Canvas because it consider you the external one,
be meetings. Hmm.
and then click join.
I can't figure it out, Professor. I'm not sure why, but when I go to Microsoft Education and then I go to meetings, there's nothing that shows up there. So I only know how to copy and paste the link.
Oh, okay. I think we can figure that out after class, that one. If you
Okay.
stay a little bit after class, we can try to figure that
Sorry
out.
about that.
That's all right. No, sorry for you not able to join
Yeah.
that one. Because I just trying to let you talk to each other a little bit. That one. Okay, so any group, any answer for that? What's the domain for the f of x? What's the domain for g of x? Any group, you can type it in the chat if you want. Anyone want to type it in the chat, or you can unmute yourself to talk. Okay, either one. Any group got an answer, or anyone can talk. Okay, so basically the domain for the f of x, x will be greater than or equal to 0, right? And so that is the domain, okay? And the range here, you can see the range here, y is from 0 to infinity, all right? And g of x, you're going to have x minus 4 need to be greater than or equal to 0. Anything under the root, everything under the root has the even root, okay? Has to be greater than or equal to 0. And then solve for x, so x will be greater than or equal to 4. And you can see this one right here, x can just start from 4. All right. And the range here is the same thing. It's all from 0 to infinity. Y is all positive infinity. So that is this one right here. And you can see because this one is under the minus 4 is under the square root. So this one actually is moving to the right for 4 units. Okay, moving to the right for 4 units in here. All right. So this is a horizontal shift in this case. If you really do not know, you can put in a calculator, graph them, and it will show you that. All right. So we can put it in a calculator. So look at this one, square root of x, right? And then we're going to have a square root of x minus 4. Okay. So that is how you look at that. So you can see, yeah, this is moving to the right for 4 units. And then if you go to second table in here, when x greater than 0, y1 is 1. But y2, you have to be wait until x greater than or equal to 4, right? So now it will start showing up in for the right one. Okay, so that's a domain and range. You can basically find this whole thing in a calculator in here, but we just have to know we just have to know like how to find a domain and range. So domain is all x value, range is all y value. Okay. And then this is the shipper to the right. Okay. If I have a square root of x plus 4, what happens? Now this will be moving to the left. Okay. So if I have this one, x plus, let's say plus 5. All right. And this one is moving to the right. I'm sorry. Compared to the blue one, the y3 is moving to the left. Okay. So that is this one right here. There's a little bit pattern you can actually see. Because horizontal shift, you using the x minus c form, okay? If c is positive, that means moving to the right. If c is negative, or you can, if it's kind of too hard to know that, you can just say x minus c, this one is moving to the right, c unit. When you have an x plus c, that is moving to the left for c unit. Okay, so that's the horizontal one. The vertical one is easier. Vertical one, you have a plus or minus is outside the x. Okay, so when you have a plus 3, it's moving up 3, right? So this one is moving up for 3. When you have a minus 3, this is moving down. So the vertical one is outside the x. So up and down, positive is up, negative is down. All right. The horizontal one is a little bit challenging because the horizontal one is a little bit different than the vertical one. So we're going to look at x minus c is to the right. X plus c is to the left. Okay. Another one is reflection about the x-axis. So what is refraction? Refraction about the x-axis is kind of like this one, right? And then this one. So you have a positive y in here. Refraction across the x-axis, this become y become negative. All right. And refraction across the y-axis is this way, right? It's this way. It's kind of like the is this way right here. Okay, so you have f of x equal to uh, f of negative x equal to f of x, right? So that's refraction across the y-axis. All right. Look at this one right here. This is a refraction across the y-axis. So how do you graph this one? Refraction. Look at it. I have a f of x is equal to q loop of x, right? And I want to reflect across the y-axis. I replace x by negative x. So you have this kind of red one in here, okay? Shrinking or stretching, okay? So I want you to go ahead and look at this graph in here, all right? So what's a shrinking, stretching mean? If I have a y equal to x squared, all right, so that is this graph, right? And then if I have y equal to 5x squared, what do you think? Is this 5x squared going to be inside or outside the x squared? Well, actually, it's inside, okay? So look at this one right here. If I have a coefficient of this x squared coefficient is greater than 1, this is called going up very fast. Okay, going up very fast is become very narrow. All right. This time, sometimes people always confuse with this one. And if I have a 1 over 3x squared, okay, this one actually is outside the x squared. Look at it. This one is kind of like a get smashed. Okay, the y through is kind of get smashed. All right, and then y2 is kind of get stretched. So this is called stretching. All right, this is called stretching. And then this one is called shrinking or called smashing, right? You kind of y increase very slowly. So I can look at the table in here. Look at it when x equal to 1, right? The y equal to x squared, that's 1. And the y2 is already increased to 5. And the y3 is, since the y increases so slowly, so y3 is only 0.333. All right, so that is outside one. Y actually is smaller. Okay, you can do a little bit vertical down and you can see that one. All right, so that is this section called a shrinking or stretching. Okay, when C is greater than 1, this is called stretching. Okay, when C is less than 1 and it's still positive, this is called shrinking. Okay, shrinking in a vertical one. All right. So that is our 2.5. Okay. We're gonna just we kind of skip the 2.8, I think. Let me go ahead. Distance and mean point formula circle. I have to check to see if we skip the 2.8 or not. Let's give a little bit syllable. Okay. So whatever we have in doubt, we check the syllable. All right, so yeah, we do skip the 2.8. Okay, so this section we stop at 2.7. All right, so okay, let's see what's on 2.6. Combination and the composition of the function. Okay, so this one is probably a little bit new in here. Combination of function, we can add and subtract, right? Find the domain for the function. Okay, so domain, if this function is a rational function, that means you have a denominator. And remember, I always say if a 0 divided by a number, that's okay. If a number divided by a 0, that's undefined. We call this one is a no. So this when you have an x in a denominator here, denominator cannot be equal to 0 because it will become no, undefined. Okay. And we usually set this denominator equal to 0, go to solve x, and then get rid of x value. All right, so if you go to solve this one, and then you add a 49 on both sides, take the square root, right? So you have x plus minus 7. So that means when x equal to positive or negative 7, denominator will be 0. So we're going to have to get rid of 7 and negative 7. And then you're going to have 3 intervals in here. Okay. One is negative infinity to negative 7. Another one is in the middle. And then the last one is from 7 to infinity. All right. Because x cannot be equal to 7 or negative 7. Okay. So let's consider the domain in here for the rational function. So we talk all these things. Domain actually only have two things. When you have an even loop, all right, when you have an even loop, everything under the loop has to be greater than or equal to 0. That's rule number 1, right? Rule number 2 here is denominator cannot be 0. Okay, so that's only 2 rules. All right, so a function you can add and subtract, you can multiply, you can divide. Okay, so that is called a function combination. We can combine two functions into one by adding them together or subtracting or multiplying or divide. And of course, when you divide, denominator cannot be 0. Okay. This one, if I want to add these two together, what do I do? Well, I just add the first one and the second one together, right? Combine the like term. So that's the addition. All right. If I want to do the subtraction, all right, so the first one is x minus 5 minus the second one, x squared minus 1, right? And then I get rid of parentheses. Okay, so this need to distribute plus 1. So if I write down in the ascending order, this will be negative x plus x. And then these two are the like term, minus 4, right? So that is my subtraction, okay? So you have an addition, you have a subtraction, and you can multiply them together. One thing we want to talk here, which is brand new for this chapter, is consider a composition. All right, composition, this is a brand new concept. Composition is kind of like a two-layer. First one is the outer, second one is the inner. So this is the outer. All right, this is the inner. All right. Okay, so look at this one right here. If I want to have F composite G, right, what does that mean? That means F will be the outer, G will be the inner. And sometimes a little bit easier to just write down this one. F of the G, okay? F composite G is F of the G. The book is doing this way. Also, you put a G of X in. This whole thing is G of X, right? And then you go to the F function is 5x plus 6. And then 5, this X can be replaced anything by the parentheses. So that is how you calculate this one. I can give you another easy concept here, okay? The second way to do this one is I'm going to the F function directly, okay? And I just replace this X by G. Replace X by G. Look at that. This is only replace, equivalent, 1X by 1G, right? So this, instead of 5X plus 6, I'm going to have 5G plus 6. Okay? So that's just a little bit easier. And then eventually I replace G in. All right, I get a G in. G is this whole thing. All right, and then I get rid of parentheses. So look at that. This is the same in here. So this will be given you to here, and then get rid of parentheses, combine the like term. So that is the composition. Okay, some people find this one is a little bit easier. And if I want to have a G composite F, what does that mean? That means G is the outer, F will be the inner. Okay, and I can go to G function directly and then replace X by F. Replace X by F. So this will be 2F squared minus F minus 1. And then we put an F back. So F is 5X plus 6. 5X plus 6 minus 1. And then we can go to do a little bit algebra. get rid of parentheses, do a little bit calculation, and that's it. That's the composition. Okay, so that's the brand new operator in this case. We also need to be able to evaluate the domain for the composition. In order to evaluate the domain, you actually have to calculate the composition in order to do that. Okay, so look at this one right here. If I want to calculate F composite G, all right, and I also want to find a domain. Okay, so we said that we have a two way to do that. One way is I find out, second way is a little bit easier. So this G is called the input. Input, you cannot throw the junk into the function. So input has to be value. So since my G is 1 over X, so input X cannot be equal to 0. Okay, and then let's see what is my output in here. I go to F function. This is my F function. Replace all the X by G. So that's 4 over G plus 2. Okay, and then G here is 1 over X plus 2. And how do you simplify this one? The quick and easy to simplify this one here is multiply the LCD here, which is X. All right, so 4 times the X, you're going to get a 4X. And then this X and X, this cancel out. So you're going to have a 1 plus 2 times X is 2X. So this is considered your output in here. All right, since my output is also a rational function, so 1 plus 2X cannot be equal to 0, right? And then you minus 1 on both sides, so 2X will be negative 1. You divide by both sides by 2. So X cannot be equal to negative 1. All right, so we're going to have to combine these two together. X cannot be 0. X cannot be negative 1/2. So we have to circle 2 points out. So this will be your domain, right? You can have from negative infinity to negative 1/2, and then negative 1/2 to 0. All right, and then union from 0 to infinity. So you're going to have a 1, 2, 3 intervals in this case. Okay, so that is the composition and also the composition domain in here. All right, I think we cover a lot today. Okay, pretty much 6th section. Let me just go ahead to see what is the last section. Okay, let me just go ahead, finish the inverse function. Oh, okay, this is another big concept, so I'm going to stop here. I'm gonna save this one to next week. Okay, because otherwise you got too much information and then couldn't digest it well. So I'm going to stop this right here, okay? We already covered 6th section for this chapter already. So hopefully by the time when you come back next Friday, you're going to also complete the 2.7, hopefully. And then next Friday, we're going to cover the 2.7 and also cover the chapter 2 review. All right. Okay, so that is all for today. Any questions? I'll be still online for a little bit while, so if you have any question, you can remain after class so we can figure it out, okay? All right, otherwise, that's it for today. All right, you want to show what happened to you?
Oh, are you talking to me?
Yeah.
Oh, I'm not sure. So when I go to, like you said, Microsoft Education,
Can you share me your screen? Can you share me?
uh, let me
Go to the very
see.
top and then share the screen. The top right, and then say share screen. Oh,
There we go.
okay,
Can
now
you
I
see
can
it?
see your screen. Yeah.
Okay,
Okay, you have to
so
log into
we're
Canvas first. Yeah, go to the Microsoft Education, click
right.
on that. All right, and then click on the meeting in the middle.
This is what I got. No meetings.
My meeting, how about not upcoming? My meeting. But
Nothing.
you should Yeah, that's strange. You are in a roster, right? I mean,
I mean, I have to be, right? Because if I go here,
yeah.
like I have your
Okay, it
class
did
right
show your
here.
course in here. So that's strange. You didn't see anything in there. Hmm.
Yeah. But yeah.
Okay, but you click this one right here. All right, let me um, let's see. Okay, I just want to, okay, let me see. I don't know why it didn't let you assign participant. Yeah, you still gray out. This person can access break room.
Maybe it's because the meeting had already started by the time I tried to join it.
Maybe possible. So next time,
I'll check here.
yeah, you check it
And by
there.
the
And
way, I think I said this over email, but I'm very sorry I didn't realize there was a class and lecture until just now.
okay, all right. So we will forgive you for the previous one as long as
Oh,
you
I
join
appreciate that
from
a lot.
from now. Yeah, it's a college requirement. They say we have to take the attendance. But I
Yes.
think that as long as you finish the weekly assignment, I still count you as attend that way.
Oh,
But
okay.
we don't want to we don't want to postpone, we don't want to do that for too long, until they say, okay, we're gonna check your team
Yes.
attendance.
Yeah, definitely don't want to get dropped. I was wondering why there's no discussion boards, and I guess this is why, because this is where the discussion is happening.
Right, right. So we basically have a live discussion, because we do
Hmm.
meet once a week, that one. And we usually have a little bit of question at the beginning or at the end, and or during the class, and then but the people usually sometimes for some reason, I have another section on Saturday. That section seems a little bit more active. This section seems a little bit quiet. That one,
Yeah, I think I
yeah.
was the only one who said anything today.
Which is fun. We actually prefer people interact, that one.
Yeah.
Yeah.
Well, I definitely need to freshen up on that last thing you were teaching about the It, there was a new symbol I saw with a circle in between the F and the G.
The composition. Yeah.
Competition.
That one is
Okay.
called a composition. So composition, you're using two layers like a peeled onion, right? Outer, inner.
Okay.
Yeah. So outer layer, inner
Outer
layer.
and inner
So
layer.
yeah. Using the onion is a little bit easier to remember. So you always work from inside out.
From inside out. Okay.
Yeah.
Yeah, I'll have to look at some of the review videos.
Mhm.
The concepts that you went over that I'd already watched the like tutorials on seem to make sense, but this is a lot of new information now, so.
Yeah, that's why I didn't really want to cover the last section for the
Mm.
inverse, because that's another new concept, and that would be too much.
Mm-hmm.
That one. This is enough. If you until next Friday, if you can finish all this six section, you are in good shape. That one.
Okay, sounds good.
All
Well, I'll
right.
try to review that. Appreciate it.
Okay, no problem. You're welcome. Okay. Anyone else has any question? All right. If not, I will see you next Friday. Okay. And make sure everyone finish the assignment. Thank you.